spotlight. So what our thought was for this month is we always jump on and we do a part here, a part there, a mill turn part. But, you know, this summer you guys saw us do this drone, and we did it all designed inside of SolidWorks. So our thought at CAMWorks is after it's all designed, all of a sudden somebody needs to make this part or these parts. So we wanted to take that kind of to the next level and show you how to accomplish that inside the SolidWorks environment using CAMWorks. As you go through it, you can see Lindsay did the first. She did the frame mount plates, which are all the green parts. She did that last Friday. And then I'm going to do the outer shell. There's a couple of them. There's a blue one here and a blue one here. I'm just going to pick the nose cone for today. It was the more difficult one to figure out how to do, as opposed to one that was just a side plate. So I'm going to choose that one here. And then next week, you'll have Daniel Lyon doing some more work on the nose cone and things like that, more of a 5-axis. And I'll show you why at the end, why that has to be accomplished and where the things went wrong from engineering into manufacturing. So the part I chose was the front one. Had our engineering team take this part. It was already designed, set up. They 3D printed it. They got it all dialed in. And then all of a sudden they handed it off to manufacturing, and they said, okay, manufacturing team, now we need to make a mold, and we need to put this into production, right? And that's kind of where we're at. So we're at almost the final stages to get this thing actually done. So I wanted to go through and show you some problems, but the problems are so far upstream that we can't go all the way back because all the development and stress and analysis and everything is already done, and it's already been approved. So that's where the CAM side comes into play, where a lot of times we have to take apart and we have to mess with it and try to figure out how to make the thing, even though we weren't involved in the design process. So some of the things I want to cover today. No need to redraw the parts in a separate CAM system. You know, it sounds funny I say that because CAMWorks is embedded inside of SolidWorks. But the reason I say this is because I go to a lot of shops and do presentations and help them with concepts and try to get their processes moving forward. And they have this great SolidWorks product. They have simulation. They have PDM. They have all these things, right? And it goes from SolidWorks design. It goes through simulation. They do all the stress. They do the testing. Everything is worked. All the fillets are set. It's all dialed in. And then they print off a blueprint, and they hand it to the shop floor, and they redraw the part and cut it. So you're not actually designing or cutting the same part that was designed. So I see that a lot out in the shops. It's easy to change toolpath and try different machining concepts. So I'm going to show you how to program this part, and on the fly I'm going to make changes to the toolpath, not necessarily the model, because the model might be locked down or whatever from engineering. They don't want me messing with it. The toolpath is on the SolidWorks SLD PRT file. So what that means for you is when you send it back into engineering, it goes into the vault, whatever the case may be, have you guys do your structure, it actually saves the toolpath on that model. So if for some reason it made it through engineering and you found a problem when you went to machine it, and they were able to back it back upstream, all the work you spent, hours, days, weeks, whatever it took you to really dial this part in, when they make those changes upstream, the toolpath, as soon as you open it back in a sheet of CAMWorks, or SolidWorks with a sheet of CAMWorks in it, it'll actually update the toolpath as well. So huge advantage to being in a CAM system that's embedded inside of SolidWorks. Due to SolidWorks configurations, so file management is huge, right? So a lot of times when you're programming a part, you have file save as op1, file save as op2, file save as op3. You have this whole folder full of all these operations just so you can actually cut the part, right? So that goes away. So this part that I had our engineering team design has a couple configurations. It has the core and it has a cavity all within the same environment. My toolpath will now be within the core and the cavity. If you do a lot of larger stuff and you're into like file management and things, we offer the PDM. CAMWorks, because it's on the SolidWorks model, checks in out a PDM as well. So those are the things that I like to make sure you guys understand by using the one system altogether. It's fully associated in SolidWorks. It updates, it does tracking, it flags you when there's changes. So like I said, based off the SLD PRT file, even if there's a change in engineering after you programmed it, when you reopen it on your computer, it'll say there's a change. So how many times do we take Rev A and we make a part, and then all of a sudden, a month later, design changes something in engineering, they pass it down as Rev B and we don't get the notification, right? This helps eliminate some of that on the notification that there has been a design change so you don't go off and cut $10,000 worth of material and have the wrong parts at the end of the day. Knowledge-based machining. So a lot more people are trying to get into this. So the basics behind knowledge-based machining, it allows your company to have everyone program the parts in the company to a company standard. So it doesn't matter if it's the day shift, it's the night shift, people who don't even see each other, they're clocking in and clocking out, they're passing each other in the hallway. It puts everybody on the same playing field. So if you're running half-inch cutters, quarter-inch cutters, speed rates, cutting in steel, anything you want to do, it actually sets a baseline for your company to where everybody's actually on the same page as you're going. Toolpath optimization, right? We use a thing called Volumill. A lot of people say, we have high-speed machining here, we wrote our own, we wrote this, we wrote that. So we actually use a product called Volumill embedded inside of CAMWorks. It allows you to go through and do a lot of high-speed roughing. So you may think about Volumill and go, you know what, I don't do a lot of high-speed roughing. But there's more to Volumill than just roughing material. Think about the wear and tear on a machine as well, right? Every time you're in a CAM product and you hit a square corner, the servos have to go one way and they turn, they go the other way, right? I know machines are set up to do that, but when you run a product like Volumill, it actually rounds all those corners. So the servos on the machines are not being hit as hard going from one direction to another direction. So not only time savings on cutting, but also saving on machines, saving on tooling, right? It doesn't load the corner. It doesn't jam a half-inch tool into a corner and then make a right-hand turn or a left-hand turn. It actually will round that corner out and keep that tool from breaking in the corner and getting such a high chip load inside there. So just some thoughts behind the Volumill. I'm going to show a little bit of that as well. And then improve programming times, increase productivity, right? So if you have 10 machines out there and they're all max capacity and all running, well then you're probably doing okay with a CAM product, right? But all of a sudden you have the engineering going through, they're passing parts out, it's going into the programming department, but the machines are sitting empty, right? Or you have setup times that are taking too long. Those are where the CAMWorks can actually come into play and actually start getting you set up to where the spindles are running constantly, and then you're shipping parts out the door. So that's the idea of having a good program to improve the programming time. So these are kind of the things that I actually want to hit on today as I'm actually going through my presentation. Like I said, at the end, if you have questions, just let me know. We can kind of go from there. So this is the mold design. So this is the part that came out of engineering. Engineering goes through and they actually set up this mold shell part. So this was the actually nose cone that you guys actually saw. And then inside of here, you can go through and then you can make the mold to be able to pull that information off of there. So a lot of times people will do a presentation. They'll just show you cutting this part. But in theory, we don't want to cut this part, right? It came out of engineering. It went into the 3D printing systems, right? We got a 3D printed part. We touched it. We filtered it. It went through the boardroom. Everybody liked it. They signed off on it. Now the tooling guys have to make it. And that's what we're going to do today. We're going to make this part and put it into a production so we can get a lot of shots off and make a lot of parts every day and hopefully make the company a lot of money. So when I get into here, I go into Windows. This is the design for one of the halves that I actually ended up with. So you can decide, see it's all designed inside of SolidWorks. I have different configurations. I have the configuration that I'm going to work on, and then I have the configuration that has a few things in it to where when it got, by the time it got through engineering, it needed some 5-axis machining on it. And with the 5-axis machining, you know, I'm not able to do it on my 3-axis machine that I'm going to show you today. And that's where Daniel's going to come in next week and show you guys some of the 5-axis work to be able to get this part actually pulled off to be able to be done. So, you know, if you're a programmer and you're ahead of time in the game and you were able to sit in engineering and get them to set it up so you can do it all very simple, great, right? But sometimes that's not the case. So today is not the case. So I'm going to jump over to CAMWorks here. So you can see I've got from SolidWorks, I've gone into the configuration manager, and now I'm going into the feature tree of CAMWorks. And I'm going to start setting the features up on the actual model. So first thing I want to do is I want to set the stock up. So if I double click on the stock, it will actually allow me to go through and then choose the stock that I actually have. Where the material is 1005, I'm going to go into tooling steel, but you know, T2, whatever, A10, depends how you're going to do it. Maybe you're going to make an aluminum mold first and just see if it actually works. You have those options inside of SolidWorks and CAMWorks. The advantage is once you program the part, say I'm going to make it out of some 1018 steel, do a couple shots, check it out, make sure it all works, and then we're going to reproduce it in some A10 and get that going. Only thing I have to change at that point really is the feed rates, right? Because the part's already programmed inside the one system. Going to hit the check box there. A couple options. I can do a part bounding box around the part. I can do a sketch around the part. Some people like to make everything out of round because round is cheaper. So you can get that for a lot less and you can get a piece of square material. You can also do an STL file or a part inside of a part if you're reworking. So cool thing about this is if I'm going through and I'm machining the actual part, I can save the simulation. When I'm done with that simulation, if the tool broke down here in the bottom somewhere, I can save the simulation as an STL file, bring it back in as my stock, and then be able to rework the material that just got broke. So instead of spending another 30 hours on a machine trying to get this tool steel all cut out, it'll come in and just work right inside of here only. Plus, once again, file management. I don't have file save as rework. I'm just reworking the original part inside the original file of SolidWorks. Have that all set up. So I have that information. I have the machines I can set up as well. So some of you are newer to CAMWorks on the phone as well. So I want to show you I have machines, whether it's milling, turning, mill turn, or wire EDM. Those are your options. I have a tool crib. Tool crib is built for the being machine specific. It can be a product line specific. You can say, hey, we cut these type of things all the time, and you know what? We always use these tools to do it. You can set it up at that level as well, or material. You can say, hey, I got a set of tools that actually only run aluminum, and I can have a tool crib called aluminum or steel, tool steel, whatever you want to do inside there so everybody's on the same page in the company. And you get into post-processors, you get down. We have a bunch of lists of post-processors at Hawk Ridge. We can go through and set you guys up on post-processors to run your machines the way they're supposed to be ran. So you can pull that information in. And then you can do, even at a 3D level, not what you're going to show next week, but you can go in and do indexing, right? So if I had to index this part and indicate to a certain direction to machine it, I could actually do that on the screen here and turn it so I could use shorter tools, right? So it depends how you want to do it. I can come in this way and I could do all the roughing here. I could do an index and I could pull the tool up here. I could do some more roughing down inside with the work in process. I could pull it up here and then I could grab this shorter with another tool. So you have those options even at a 3D level to throw it on an indexer and be able to cut your tools off here, turn it, index the part, come in and rework inside here, turn it the other side, and then rework the other side. So all that is capable inside of our software at a 3D level. And then you will see true 5-axis machining next week. So I'm going to hit OK on that. And then basically I just want to start setting the machining process up, right? I don't need to redraw anything. I don't need to redesign anything. I don't need to look at a blueprint and draw a part. Right? I just have to cut what came out of engineering or what the model they actually gave to me. Whether it's SolidWorks design or you get it from a customer, you import it as a Parasolid or an IGES file or a step file, it's still going to do the same thing that I'm going to show you today. So if I right-click on the stock manager, I'm going to insert a mill part setup. So it pulls the setup actually off the top of the part. So I can reverse it, change it if it was wrong, whatever the case may be. I'm going to hit the checkbox. I have an option here as well, I should point out, that I could put in the strategies as well to machine the part. But I want to show you some different ways of actually getting through that. This is what we call as a select all. So if I hit OK right here, and I right-click, and I insert a multi-surface feature. So I'm going to pick on that. I'm going to have faces and surfaces to pick, right? So I can go through and manually select. So I'm going to show you a couple of different ways today on how to be able to do this. I can do all displayed. It just picks the whole part, right? So if I'm roughing it, I probably want to pick all of it to rough it. I can do an STL file. I can just have a small STL file on the screen and pick the STL file when you guys run a scanner or whatever the case may be. Faces by color. So if you said, hey, you know what, cut the blue face, cut the red face, cut the purple face, you could set the faces up and machine those as well. Or faces by a surface finish. So this is newer to CAMWorks. This is what we call our TBM, taller space machining. It allows engineering to go, hey, this has a 32 finish on it. So you might have a set of routines inside of CAMWorks that runs a 32 finish, and it'll actually pull that information and it'll apply it to that surface and cut it that way. So that's where you get the knowledge base that I was talking about. How do we do machining at our facility? So if I get into this, for this one, I'm just going to pick all displayed for right now. I have different strategies, right? This is, once again, this is save knowledge into the software. How do we want to cut the part? So very simple, very small, very clean. This gets anybody started out of the box, right? But now you want to start building different ways of doing it. Maybe you put in a rougher, and then you put in a pre-finisher or a pre-rough, then a finisher, and then a pre-finisher. Whatever the case may be, you can set that information up. I'm just going to pick the top one here, and it just kind of shows me it's going to be a 3/4 inch. It's going to be a 1/4 inch ball end mill. It's pulling out a tech ID number 191. I could go in there and make changes on the fly if I wanted to. Not going to get that today. So if I pick on the checkbox here, it gives me the information. Then I can start applying the information to this actual model. So it's going to say, hey, your surface finished. I'm going to right-click and then generate an operation plan. I can also just go through the tabs up here. You can see everything is grayed out, right? So I just pick on the next thing that's available. I already put this. I'm going to click on this here. I'm going to pull that information. Next thing I'm going to generate the toolpath. I'm just going to apply toolpath to the whole entire model, right? I don't know what it's going to look like. I'm brand new to CAMWorks, or I don't know, really what I'm looking for. And this is what I talked about earlier. You have ease of use on changing tools and the way you cut things based off what looks good to you on the actual screen. So I have an area clearance. It goes through and it roughs out all the material, right? Right or wrong, it's roughing the material. Next thing is a pattern project. I can look at that, and it goes through and it just lays the toolpath on the whole actual model. So you have that as well. Maybe you want to go in there with a larger tool to begin with and then pre-rough it before the finishing tools come in. So I can go to the area clearance, and I can find a look at that, and I can kind of simulate that. So if I right-click and say Simulate Toolpath, it'll show me my toolpath I actually want to run. So I can go through and I can pick on that, and it starts running my part. Let me slow this down a little bit here for you. Let me just go to one step. So if I pick on that, you can see it takes everything at one level at a time. That is so the tool does not break. This is the standard way that we used to all rough before all the Volumill, tricotal machining, and all that started showing up a few years ago, right? So this took a long time to rough apart. You can actually do this with what we call Volumill and be able to remove the material a lot quicker. So the idea with Volumill is you can take the step down farther and then go back and then work the walls going back up. So just cuts down times and things like that. So let me focus on that first. I'm going to take the area clearance. I'm going to go through it. And then the different patterns that are actually inside here. I have the tools. I can choose different tools, 1/2 inch cutter, 3/4, 1 inch, whatever I want. Feed rates, how fast do I want to go based off this material? And you're more than welcome to change this, right? If you pick on library, it's grayed out. I can't touch anything, right? I can pick on a tool. The tool says, hey, based off what we've done in the past, it'll run at 3,500 RPM, 57 inches a minute. That could be your company standard when you run the tool. Or I can go to the operation, right? And of course, I can override anything I want. And then I can just start making changes. Say, hey, you know what? I've been cutting this stuff forever. It runs at 4,500 RPM. And I can push it to 65 inches a minute. I can set that information. Different patterns, right? Pocket in, pocket out, lace, adaptive. So these are all standard. And then the Volumill is an additional thing that we actually get for a lot of our customers. So I pick on the Volumill. Things change a little bit. Pattern is changing the Volumill feeds and speeds. I hit yes, and now it actually gives me the information for the Volumill, right? What kind of material am I going to run? What feed rates do I want? What's the max of the machine? What kind of alloy? Is it tool steel? I can pick on tool steel today, right? And then kind of go through the information. Is it a 40 taper, 30 taper, 50 taper? How are we holding it? So all these questions I can actually change, and then you can say the conservative is right here, right? RPM is 4240, and then the max is 51 is what it's recommending. I can just slide this bar across, and you can see when I pick on that, it says, okay, well, this is what you really like. Or I can fine-tune it, right? And I can say, well, give me somewhere close to 5,000, and I have that 5,000 set up inside there, RPM, 112 inches a minute. I hit OK. It automatically applies all that information to the feeds and speeds tab. So you can see my toolpath is still up a little bit. I go to my area clearance. What's my max cut amount? You know, I don't want to go above 1 inch, right? But I really want to work the walls coming back up so I don't break the tool. So I'm just going to hit preview on that. And then what it'll do it'll take all those tool paths that you saw that were going down inside there, and then what it'll do is it'll take those, step it down 1 inch at a time, and it'll take the tool, it'll actually bring the tool back up the wall to be able to do the finishing that's actually inside the part. So you don't have to step down 100 thou at every layer based off these new algorithms that run up inside the background of making this thing actually work. So the 98% calculation, it'll jump up here in a second. Cool thing about it too, you can see the time, the information that goes with the volume mill, puts it at 100%, shows me the start time, the end time, what it took to calculate it. So now you can see the tool path is a little bit different, right? It goes one layer down, hogs all the material, and then it works itself back up on the material. So it allows you to get through the part a lot quicker, machining, things like that, saves on tool life as well. So now if I was to simulate it, you can look at it, and it'll actually drop down to the bottom, and we'll start working the part as it goes through there. I'm just going to do one layer right here based off our time and stuff we have going. And you can see it works across, and once it's all done with the information inside there, it'll then work back up the walls. So this stuff is great. I actually run it on my own machine all the time. I get longer tool life out of it, and I also get faster parts. Something that might take me 10 or 15 minutes to rough out, I can now go through and I can rough it in like 5 minutes or 3 minutes or 6 minutes, whatever the case may be, because you can see how it actually works. It doesn't take each level all the way down the steps and cut all this extra material. Just steps it down as far as it can go. Just remember, it likes to do double the diameter. So if you're running a 1/2 inch cutter, you can run it 1 inch deep. And if you're running a 1/4 inch cutter, you can run it a 1/2 inch deep. Just keep that in mind, and you're kind of good to go from there. So I have that, but like I said, if you're the old way of doing things, I can go back to pocket out. I can change it, whatever I want. I can set the feed rates again. I can set whatever I want inside here and make those changes. So just to give you an idea how that's all set up. So area clearance, I want to go through and I just want to take this part and rough it all out. And you can see things start to open up inside of here, right? And gets a little bit crazy and gets big scallops in there that are probably not acceptable for the mold industry, right? We have to get that set up inside there. So, but what I can do is I can make those changes. Maybe I want to take a 3/8 rough or a 1/4 inch rough or whatever, right? And I just want to kind of pre-rough this part in to get what the larger flat-end mill couldn't get before I go in and start doing detail work. So I can take this information, cut them out, and I can change this. I'm just going to leave this at 0.025 just because we're on a web meeting. I kind of want to calculate this a little bit quicker. You guys are going to run this at a 10 thou step over, an 8 thou step over. You're going to start knocking this down to 5, whatever, to get that mirror finish because everybody hates polishing. So let the machine do all the work. I'm going to hit preview. It's going to recalculate the tool path based off of that 0.025 step over and just give me a little bit of a nicer finish down inside there. So you can see the process starts here, the start time, and then there's my new machining algorithm, right? And you're going like, okay, well, that's great, but maybe I don't want to go down there in every part, right? Maybe I only want to machine around the top edge. Then I want to machine this separately. You can do all that, right? So let's pretend this is a pre-rough. We're going to change this to a 3/8 ball end mill just to get down in there and clean everything up. I'm just going to go down and grab whatever that might be. So I can say it's going to be a 3/8, or maybe it's a 1/2 inch, right? Whatever you guys prefer. I'm going to select that, and then I have that tool to go inside there. And you can see this tool is short. So we do have ways to contain the tool to stop halfway down so you can get really fast feed rates out of a short tool. And then I can say stop right here, grab a tool change, and then take the larger tool and then drop it down to here and get all of this information out of here in the material. And then take the long tool that takes 5 minutes per inch to cut and, just take an extra 3 hours and get down and do all the detail work. So you do not have to use the same tool to run the whole entire part. That is really just based off our positioning where we get in to actually do things. So I can say, hey, there's a limit. It's top of stock, halfway down. I don't want to go to the bottom of stock. I can go user define, and I can control that. And then I can pick apart on the model, and it would actually stop inside that model and be able to do that. So just to give you an idea, guys, an idea that you can actually be able to do that information inside here. So I don't want to change the tool path. I already updated that, so I have that all set up inside. So you got to remember, early on, I selected the whole model, and that's why I got everything to rough, and I have everything to finish. But now I want to start detail work, right? So I just come back to the feature tree. Like this is an operation where all the tool path happens. These are the features. I'm going to right-click, and I'm going to insert another feature. But now I'm just going to do picking, right? So I can do faces that I want to select. I can choose on that. Once again, all displayed are colors. I'm going to pick on this. I can do a window select, or I can just, hey, you know what do you actually want to choose inside here? And I can just go around and I can start picking the faces I want to cut. So I can choose this, and then it'll actually allow me to set that information up to machine that surface only, right? So I have that as an option. So I'm going to leave on area clearance and pattern project because a lot of people forget to change this, and I'll show you how to change it on the other side as well. So I'm going to check that there, right? I do want to put in another one. I want to come inside of here. But when I get inside this one, I don't want to go through and pick all these because I might actually miss something, right? So I can go through and I can turn this up on its side, and I know I can pick a little box and make this go whatever way I want. I can right-click, insert another surface, and then what do I want to choose? I can choose options down there by a window. I can do adjacent faces. I can select all, right? I can do here, highlighted faces. So if I just do a window and I choose my actual window inside here, it's not going to take all that. I'm going to unselect that one right there, and now I'm just going to machine down inside there only. But I did not have to go pick, and I missed something. All of a sudden, I gouged the part, right? Tool crashes through the side of the model. So I'm going to hit the OK button right here. And now I'm just going to take these, and I'm going to generate an operation plan on those two only. So you can see I have my area clearance, my pre-rough, I'm calling it, and then I have my other area clearance, which I don't need anymore, right, because they're already roughed out. So I'm going to take my control key, and I'm just going to delete those. So if you don't want anything, by all means, just throw it in the recycle bin, right? Now I have another pattern project. So if I want to go in here and I want to right-click and generate toolpath, it's going to take my pattern project, and it's only going to cut the surfaces that are actually up on top of that model by doing that. So I don't have to worry about going down inside anymore. It's just going to machine this here, and you can see I get those surfaces to cut, and I can clean those up with step overs, finishes, whatever the case may be. Now, the pattern project is not what I liked inside, right? Because you saw it had some scallops in there. I might want to do a different type of a toolpath. So CAMWorks has several different types of toolpath. I can come in here, and I can say, what do I want to do? And I just insert another operation. I have another area clearance. I have a Z level, which the industry knows. Flat area just automatically analyzes the model, and anything that's flat on it, just plug the toolpath on top of the flat. Pattern project I showed you are constant step over. So I pick on constant step over. I look at this. And I start going down through here, right? It says, what do I want to hook it to? I just want to hook it to this right here. And it shows me that toolpath right inside there, or where it's going to go. Do I want to edit the operation? No, I'm just going to leave the flat end tapered on there. I'm just going to hit the go button, right? So when I hit this go button right here, it's going to start processing when I right-click and generate the toolpath. It's going to start processing the actual toolpath inside the part, right? But as I go through this, you got to kind of realize, did I choose the right thing or did I not choose the right thing, right? And it kind of sets that information up, and then that's a better toolpath now. So I can go through and do that. So by doing that, I now have my area clearance, a different pattern project with a big ball end mill, right, that's not going to break off down inside here to finish like a pre-rough, and then a pattern project to do the top edges, which I can tune down that as well. And then I have a step over down inside there to be able to pull all the tools information inside, so I can mix and match how I want to do things. So this one right here I don't even need, right? So once again, right-click and just throw it in the recycle bin because I didn't use it. So the idea is mixing and matching and changing things really quickly on the fly, right? So have I fine-tuned it? No. Did I change a step over and set it to a 5 thou step over or a 10 thou step over or a half a 10 step over, whatever you guys want? I haven't done that yet, right? Have I gone through and changed the feed rate yet? No, I haven't done that yet either, right? But by concept, you know, in the last 15 minutes, I have toolpath applied to this model that looks like something that Tim Folden would like to machine it this way with this using these toolpaths. Then I can go through and start tuning it up now, right? I can click on this ball end and go, great, that looks really good, but why do I have all these rapids up here? And you can start changing, right? It's links. Whoever set the default, set it to 0.2. Let me set it to 0.5. Maybe I want to change the step over. So, you know, it's set at 100 thou. So out of the box, you may go, this is crazy. Why would you do it 100 thou? It's depending on your model, right? I'm doing a small nose cone. Let's take the hood of a car. That takes 3.5 hours to calculate the toolpath on the hood of a car, right? By setting your defaults a little bit larger, it allows you to get the concept Look at the toolpath, see if it's something you would like to run, and then you could fine tune it, right? I can knock this down to 0.02. I hit the preview button, sorry, 0.02, make it even larger there. And it'll take that toolpath and it'll start fine tuning that toolpath now. So that is the basic way of getting the concept down and then going through the calculations inside there. And you can see it's calculating. It goes through, it does all of its stuff, and it does what it's supposed to be doing inside here. And now I have a nice toolpath and a nice finish down inside there. And now I can set the feed rates and then go for it and start cutting the actual part. So that's a basic idea of going to do it, getting the part from engineering through simulation, through the 3D printer, and now all of a sudden you're using that same model to put the toolpath on. You're not redesigning and trying to guess what the fillet was supposed to be, or you're fudging the numbers on the shop floor and going, well, engineering said it at 1/8 of an inch, but those guys don't know anything outside there. I cannot get an 1/8 inch tool that deep in the model, right? Well, like I said early on, we weren't in the engineering phases on this part. We're now stuck with doing this model this way. So we have an option, right? We can go out to an EDM sinker, and then we can rough this in the best we can, and maybe those tools we can get down in here. Maybe you guys are comfortable with a 3/8 cutter, right? A 3/8 ball end mill with a long shank on it that's really stable. Maybe you have one with an insert, has a taper going up on it, and it's really detailed down inside there. But we cannot get the fillets that came out of engineering that's already signed off through approval, right? So now we need to build an electrode for it to come down and actually cut this part. So we'll get it all roughed in, we'll take it over to the sinker, we'll put the electrode in, and then we'll start cutting this information down inside here with the sinker. So based off of that, I'm just going to hit OK. I don't need to regenerate anything, but now I want to go and I want to find this part that somebody built to make this mold. So if I get into this part, I go into Windows, right? I'm going to pull this information up inside here, and here's the part that they actually gave design to build the mold with, right? They got the fillets too tight. This looks not bad because this is an external radius, right? So the hard part about building the mold is like what's internal, what's external, stuff like this. If I was going to cut this, here, it'd be difficult because I couldn't actually make this fillet. But you got to remember, this is a reverse side of this actual part. So now we want to go in and we want to turn this into an electrode so we can throw it on the sinker and then put it in the wire EDM machine, or the EDM machine, sorry. So first thing I want to do is I'm still in SolidWorks. I'm not building a new model, new configuration, trying to figure out. I'm just going to work off the existing geometry that's been given to me. So I can pick whatever plane I want. I'm going to pick a front plane. I'm going to go normal 2, right? Now this is where engineering gets all excited because I'm like the hack master when it comes to SolidWorks. So, but I'm not concerned about the design side. I'm concerned about getting that spindle running and getting the parts out the door and getting production running. So this is where you can go back to engineering, have them fix it for you, or you just sit here, you get it done, you get the part done, then you go back to engineering, have them fix it, or whatever you guys want to do. So I'm going to pick on a sketch, and I'm going to set that sketch up inside here. So I'm going to take it, and I'm going to do a rectangular pocket, right? And I can put dimensions on here, of course, but for the day, I'm just going to throw something on there. So I'm going to call that my sinker electrode. Right? So I'm going to come into here, I'm going to go through here, I'm going to grab another one, and then basically I'm just going to cut this apart, right? Like I said, I can put dimensions, whatever you guys want to do. So I'm going to go to features, I'm going to do an extrude cut. And then I can tell it how deep do I want to go. I'm just going to drag it through the actual model, and there's my model with the extrude cut coming through it. I check that off. You know what? It's starting to look like my sinker now, right? So I'm going to tie this now to the holders so I can put it inside the machine. So if I want to put a block on here, by all means I can. So if I just pick right here, I can open up a sketch, right? Normal 2, SolidWorks, right? Do a sketch, put in a square block. I mean, it depends how detailed you want to get. You can tune this into an actual looking part, or you can tune it into a part to get you something, some graphite or some copper off, and start running the actual part. So I'm going to take this features. I'm going to do an extrude boss out of this. I'm going to set this thing to say maybe 0.75 for now. I'm going to pull that information, and now I have my model set up inside there. But I have an issue, right? So if you look at this, if you actually were trying to cut this, CAMWorks would show up with this, right? I don't need the block this big. I just kind of did it for design, right? So all I have to do is right-click, and then I can just edit that sketch, and I can drag that sketch down a little bit, hit the rebuild here, and just go ahead and close that, right? And now I don't have that problem anymore. Real quick, real fast, just trying to get some tool paths, right? So now I have that information all set up inside here. Same thing, right? Now we're going to work on the sinker. So to get the detail down inside the bottom of that mold so we can actually achieve it. So I'm going to go to CAMWorks tab. I'm going to right-click on this and edit definition, right? It closes up my stock to where it actually fits all 6 corners, and I hit the OK button. Next thing I want to do is right-click and insert a mill part setup, right? Finds it off the bottom because that's a good flat face. So CAMWorks just said, hey, you must want a machine from this. Well, it's not the case. I want a machine from the top side. Hit the OK button here, and then I just start adding my same toolpath as before. Right-click, insert a multi-surface feature. What I want to do, I want to do all displayed. I'm just going to leave the standard things here, and I'm going to hit the checkbox here. And it's going to ask me, hey, you realize there was a configuration along with this. Do you want to build me another configuration? And I can set that up inside here. So CAMWorks supports SolidWorks configurations. It also has its own CAMWorks configurations. So you can say, this is a toolpath for the mold. This is a toolpath for the electrode. This is a toolpath that we're going to take it off and we're going to put it in the turning machine, right? And you can set all that information set up inside here. Once again, file management, great structure, in and out of the same folders, in and out of PDM, however you want to do it. I'm going to hit the OK button right here. I don't need to rebuild anything at this point, and now I have the features. I'm going to right-click. I'm going to generate an operation plan. So now if I just generate toolpath, maybe I don't even need this, right? It's electrode. I don't have to do anything fancy with it. I'm just going to generate toolpath on the actual ball end mill. So now it's going to come through and start calculating the ball end mill to start building my electrode that I'm going to actually run. Once again, shows me the time, and now I have the ball end mill inside there, right? So I have that. And maybe that's kind of my pre-rougher, like I said. For some reason, I like to rough with one tool and pre-rough with a ball end mill that's a little bit larger, and then go a little smaller than that. Now, earlier you saw me go back over here and keep adding features and keep adding parts. But because I selected all in this one, I really just want to add a smaller tool. So if you hold your control key down and you just drag it up, you now made a copy of that pattern. I can take that and I can drag it back down. I can double-click on it. And now I can go through and then put whatever I want inside there. I can go to the tools, go to my tool crib. Well, we've always built big molds before, and now we've got to fix this one, and we don't have a ball end mill small enough. I'm just going to go to Add Tools. I'm going to choose the tool off the ball end mill list, and I can go through. Is it an 1/8 inch? Is it 2 flute because I'm running softer material? Do I still want to stick with 4 flutes? That's all we have in the shop. So I'm just going to pick the 4 flute, choose that. I'm going to hit OK, and then it's going to ask me, hey, do you want to use this? So I can see visually real quickly that this tool would actually clear, right? Oh, wait, it's not going to clear. When I get down to this corner, it's actually going to gouge my material, right? So really what it is the protrusion link that's inside. As I said, this is where the detailing comes into play. I still want to use the same tool, 4 flute, you know, with the right length of cut. So I'm going to select that, and then on this window, I actually have my protrusion set here. How much do I actually want to push out? So I have the overall length, the flute length, right, on the tool holder, sorry, protrusion right here, and I can start adjusting it to what I need. So I can go down here to 1 inch, you know, probably a little long, might break the tool off. So when I set this information, it comes across to the setup sheets, and it tells the people in the setup what it actually needs to be set to. So that would actually work. It'll go up and over that, and I'll be able to cut that part. And then down in those pockets, and whatever the case may be. Other problem is I don't need this big old step over. I'm fine-tuning this thing. Let's just do, I don't know, let's shoot for a 10 and see what happens. So to pick on that, I'm going to hit preview, and it's now going to go through and actually start cutting that part with a 10-thou step over, right? So now I have, in the background, I have my machine all running, right? I got this all set up now with all my tool paths, and now I have my electrode to go through and do that. I'm going to hook my holder to this, and then I'll sync it, and I'll get it all detailed out. So that's the idea of being inside of one toolpath, one concept when you're actually doing everything. So when you push this back upstream, it goes back into engineering, goes back into files. If somebody looks at this, let's say you never even communicate with engineering. They took a look at this and go, what has Tim done to this part? This is not what I gave him. And they get up out of their chair and they come storming in the programming department. They're like, what have you done? And you explain it to them. All of a sudden, you might, if you're lucky, you now have a more open communication, and they might come down and ask you, hey, you did this last time. Do you need another one? Instead of you hacking my model up, can I actually give you something that works? right? And then now they're doing some more design work and giving you the processes and things like that. And I can cut this. We know that you're not going to burn just one of these. You're going to step it down. Maybe you have one that's 5 thou too big, then you go down to 2.5 thou, and then you go down to the actual size, right? Well, do I have to redesign the model? No, you don't, right? I can get into the finished sizes here, and I can adjust the allowances based off of that. So I can say, hey, you know what? Take this one and add 5 thou to that, right? And we're going to call this our rougher. I'm going to add 5 thou to this, and I can adjust that as well. So you can do it that way, you know? Programming, guys, great way to try to just figure things out when they don't work. I can also come over here and I can lie to the tool. I can say it's not a 1/8" tool. I can say it's a 0.30 tool, right? And all of a sudden it stays away from the model as well. So you have a couple of options inside here. The cleaner way is to go through and just set your allowances up inside of CAMWorks, leave 5 thou over the part, cut your 5 electrodes, drop it to 2.5, cut your 5 electrodes, drop it to 0, cut your 5 electrodes, right? And then when you're burning the part, you have everything set up inside there. No need to redesign the part when you get into it. Comes up with me a lot of times. You'll say, hey, well, it came out of engineering. They have +10, minus nothing. They don't draw it to the right net size when I'm going to cut it. Well, inside of CAMWorks, you just make those adjustments. You don't have to go back, storm into engineering, or back to your customer and have them make all these changes, and then you wind up losing the job, right? CAMWorks has a lot of ways to get around things that come through the SolidWorks environment from a manufacturing side and a programming side, which allows you to get the parts done a lot quicker. But, you know, you just got to think outside the box a little bit on what you actually want to do inside there. And now I have my allowances. I just hit OK, and now it's set up, and all my tool path will come off that part a little bit, and I'll be good to go. One other thing, it doesn't pertain to this part, but you can actually go through and you can move things around as well. So if I want to do other stuff, I can do that if I want to as well. So I can go through and I can drag this up. I can drag that first. I can drag this up and go first. It's not pertained to any certain order. So as you start going through the actual model and you're like, oh, wow, I was over here on this other window. I got this one. I got thinking about it. I probably should have did something else first, right? You could take this right here, and I could take that, and I could just move it up, and now it's first. It doesn't matter, right? All people program things differently and get stuff set up inside there. So that is kind of my concept on this nose cone. I know there's probably like a bunch of you people on this phone, and you're like, I wouldn't program it that way. And you know what? That was my point. It doesn't matter how we all program. The idea is CAMWorks is flexible enough to where you can program it your way and get your stuff done the way you like to do things to get it processed. So hopefully that answers some of your questions on site here. I do have a question and answer thing. It's not a very big window, but I'll do my best to actually get through those, and we can kind of go from there. So to finish this up, just to give you an idea here, right? Did the 3-axis programming, same system, toolpath is on the model, associated with the SolidWorks model. And then this is for next week. So this is where if you guys log back on next Friday, same time, 11 o'clock Pacific Standard Time, you'll actually be able to see the next parts inside that actual part. So when you look back up inside here, you'll see other stuff being machined. So we got through all the green parts. We nested it last week. We cut it. We built the mold for the nose cone. There's some issues with the second half of the nose cone. They can't be done in 3-axis, but it's too late. It's already been through the concept. So Daniel's going to show you how to do that on a 5-axis machine, and then show you a couple other features inside the part so you can actually get the thing actually going. So that is it for me. That's my 45 minutes. Next 15 minutes is for questions. If you have questions, I can try to answer those. If not, you're good to go. Thank you for joining me today.